Okay, so welcome everyone to our virtual tour of our passive house that we're building in Weston, Mass. You can go to the next slide. A couple of quick housekeeping notes. Tour is going to be recorded so people can access it later on our YouTube channel. We have multiple speakers covering separate sections, so we'll leave a little bit of time at the each of one of those sections for question and answers. So what we have planned for the afternoon is a brief introduction to everyone on the team. Ken Tatro from Chris Williams Architect is going to discuss the site, the design of the building, and the building envelope. I'm going to cover the foundation frame, exterior insulation, and the foundation. Sam Wallace from Lavallee Systems, he's going to cover the mechanical systems. And Malcolm Sonnett from Revision Energy will cover the battery, solar, and the power walls. Just a brief introduction about us, Auburndale Builders. We're a residential construction company founded in 2005. We specialize in high-performance custom home building and remodeling. A few of our more notable projects recently: the first passive home in Mass, the first all-electric net positive home in Newton, Mass. And we also built the first certified passive office in Newton, which is our headquarters. And then I'll just hand it off to Ken to introduce yourself.
Hi, everybody. My name is Ken Tatro. I'm with Chris Williams Architects up in Meredith, New Hampshire. Thank you for joining us and taking time out of your busy schedules. We've been designing sustainability since 1984. We work and design high performance and net zero energy project designs. Our main focus is single family and multifamily homes. We also work in the educational hospitality design fields. And our projects are found in New England and abroad. So the homeowners approached me to create a primary residence having net zero energy design goals. This would be using sustainable practices, having advanced framing, insulation, materials, and systems, which is similar to what we use in their New Hampshire vacation home. If anybody's interested in seeing that, you can go to NewHampshireHomeMagazine.com, and it's a 2020 project, and it was a July-August release. This home in Weston, Mass would also provide open concept core living space. So it would have several spaces within a space, and it would be suited to their lifestyle and can accommodate large gatherings of friends and family. It would provide comfortable, healthy, low carbon living environment by using thoughtful building assemblies, practices, and systems. And we would be optimizing goals within challenging site limitations. This would be providing accessibility and offering aging in place consideration as well. Let me just scroll down here. The client's building program goals for the Weston home shared a number of similarities to their New Hampshire home. Likewise, this Weston home has considerable floor area, which presented challenges to meet the net zero energy goals. Also similar to the New Hampshire home, the design required considerable efforts to reducing the visual perceived size of the home and addressing the total boxy stereotype that comes with the energy efficient home design. Additionally, having a GC with experience in these advanced systems would be necessary to meet the goals. This is an aerial view of the site. The original house is shown in the center, and you can see the clearing. So the challenges included building program goals having considerable floor areas, as I mentioned before. The limited site area is another challenge, and the building program goals limited proposed structure to the location of the original home or within this cleared area. Addressing municipal limitations for homes greater than 6,000 square feet was a challenge. The tree removal was limited. Grade adjustment and roadside curb cut adjustments were not allowed, limiting us to utilizing the original driveway location, which is towards the bottom right of where you see the house. And all of which limited passive solar and PV opportunities, so we needed to be creative. Okay, if you're able to see this, this was an energy model that we had done, and it offered insight into available opportunities and offered better understanding about choices being considered. Shading from the existing trees were actually measured and used in the model to help determine heating and cooling loads, as well as potential solar energy harvesting. Initially, my assembly design included use of rock wool insulation for the entire continuous insulation package, but we moved towards a reclaimed rigid foam, which is acquired at a lower cost and has already shrunk and off-gassed. This will be discussed a little bit later. Okay, the next slide. The client was sensitive to the typical look of roof-mounted PV array, so we designed the panels locating along the southern side of the ridge, the roof ridge itself, and it was intended to appear more like a linear skylight. We also determined that the best opportunity for solar exposure, considering the low roof compared to the tall trees in front, we determined that the ground-mounted array would be also necessary, and is shown in the backyard, the north of the yard. Okay, the next slide. So rather than the typical ground-mounted solar array, the yard was also quite small compared to what we were trying to fit on the site. Yeah, so in lieu of a ground-mounted PV array, which would occupy prime yard area, the design includes a raised array as a rooftop on top of a timber frame pavilion. So this allows us to utilize the space underneath for as protection from the sun, or for lawn lounge chairs, and we could even attach swings, bench swings to it if we want to. Okay, the next slide. Okay, this next slide shows the main level. The interior building program goals required accommodations for large gatherings of family and friends. The main level design includes a central open concept core living area consisting of several spaces. And these are developed in a manner that keeps the space to a comfortable scale. The master suite and laundry is located on the main level, and the design includes a 3-car garage with charging capabilities for electric vehicles. The demising wall between the garage and the living space is a thermal wall, which separates the 3 levels of the garage wing from the main level, or from the main house. A mudroom and pantry separates the garage from the kitchen space and provides access to the built-in barbecue in the back. And the layout makes efforts to bring southern natural light into the living space. The southern exterior wall fenestrations are designed to allow southern light to reach into the living spaces where possible. And the kitchen south counter is actually located along the bottom of a large window, is intended to double as a light shelf to reflect southern light deeper into the core living space. The large exposed beams offer clear span across the living space and the core space without the use of columns, and they're also oriented north to south where they hang down below the ceiling, and that also allows southern light to find its way into the core living space and wash the ceiling with light. The great room also takes advantage of eastern light and opens out into a generous deck to the backyard. Okay, the next slide. The upper level includes a balcony that looks down into the entry into the great room. An office is located along the south wall, which, along with the entry glazing and stair orientation, provides additional southern lighting ability to penetrate deep into the interior spaces. Sleeping accommodations are also provided for guests, and a generous storage and craft space is located above the garage and is also separated from the living space by a thermal wall. A three-stop elevator also provides access to the entire home. Okay, next slide. Okay, this is the lower level plan, which is pretty large considering it's a net zero energy effort. The original design did not include usable space below the three-car garage. However, a pre-stressed plank system suggested by the GC offers a great space to house the Tesla power walls for storage. And they also require separation from the home, which this does great. The demising wall of the lower garage space is a thermal concrete wall assembly. Sometimes when we make a suggestion, it might seem far-reaching, and it was fortunate that when I suggested consideration of a plywood floor system for the lower level over thick, rigid insulation in lieu of the traditional concrete slab, that the GC was familiar with the approach and the client was open to it as well. The effort reduced the embodied energy of concrete, which also utilizing reclaimed rigid insulation, preventing it from landfill, and which is already off-gassed. The result is a much more comfortable floor to walk on as well. Okay, the next slide. Okay, we're looking at the front entry elevation and the rear north elevation. The client wanted exterior assemblies and materials very similar to the New Hampshire home. Exterior siding finishes are over continuous rain screen, weather air barrier, and 4 inches of insulated systems. The client also wanted stone veneer, which offers durability at the grade level, and of which required a system designed to include both rain screen and the continuous exterior 4-inch rigid insulation system. The client also appreciates large overhangs, of which were arranged to provide passive cooling by shading glazing from the summer sun. Multiple levels of roof design and overhangs are used to reduce the perceived visual size of the structure. And the roof design is intended to offer protection to the entry and the access points to the deck from stormwater runoff. The roof includes 2 layers of plywood, providing continuous venting above a thick, dense packed roof system. Okay, the next slide. This slide shows a section going through part of the building, and we've learned a great deal from predecessors in the industry, particularly that considerable care is required in the layering of material systems of the building envelope in order to perform as intended. From the exterior working in, we use the finished cladding as both visual and aesthetics, and as protection to the layers below. Here we provide rain screen over continuous weather and air barrier membrane, shown in blue, which is traced around the building's exterior boundary and covers the continuous thermal exterior insulation system. The roof is vented above the weather air barrier membrane. And the stud framing is filled with a dense packed cellulose, which is separated from the interior space by a variable vapor barrier control system. And that's shown in green, and which is continuous if you follow it around that section. Interior finished cladding is installed over the vapor control layer with considerable care to ensure that the vapor control layer remains continuous. Okay, the next slide. This slide shows a strapping plan, so a roof plan with intended strapping. And if you look close, you'll see that there's a layer of plywood that the strapping goes over. We also have holes that go through the plywood and has a vapor open patch to it. And these straps are actually separated where they join. You can see there's a space between the butt ends of them, and this will allow venting to find its way between the different rows of strapping. If you look at the plan, you can see that the strapping in certain areas are at a diagonal, and that's to bring venting to the critical areas that normally don't receive any venting, such as valleys. Okay, the next slide. Okay, so we're at a question and answer spot. So if anybody has any questions, go ahead and shoot.
And people can also put questions in the chat box as we're going, if you think of questions and you don't want to interrupt the speaker.
There are no questions yet, Ken, so I guess we'll just continue, Ryan, for your section. And then if any questions come up, as Nick said, just throw them in the chat and we'll circle back.
Sounds good. Yeah, so I was gonna just talk about some of the construction techniques that we use on the project. The foundation assembly, we had mostly 12-foot foundation walls. Our assembly required a little bit more of a rigid structure. So if you can see in the photo, those 2x4s that are horizontal and vertical are bolted back into the foundation. We also have 4 inches of rock sill insulation attached to the foundation. The reason for all that extra framing and structure is to because of the stone veneer. Also, the insulation spaces us off of the foundation. So normally you could have just adhered to the foundation with your stone veneer and that would have enough structure. But for this assembly, it's 2x4s horizontally bolted into the foundation, and then vertical ones bolted back through that first ledger into the foundation as well. For the inside of the foundation on the interior walls, that also has 1.5 inches of salvage polyiso with a 5.5-inch interior wall. That's also filled with dense packed cellulose. So our entire foundation wall assembly is an R40. You can go into the next slide. For our basement floor, we installed a concrete free floor assembly. This is a variation of an assembly designed by architect Steve Basic. He's written a couple of articles about it in Fine Home Building and Green Building Advisor. Ken mentioned this assembly before. The process is very similar to pouring the concrete slab. Once our underground utilities are set, we end up just spreading out and compacting crushed stone and pea stone. We have to take a little bit of extra time to make sure that that sub base is completely level. On top of that sub base, we install 3.5 inches of EPS insulation. Actually 2 layers of that gets staggered. On top of that, we install a 10 mil poly vapor barrier. And on top of that, an additional layer of 3.5-inch EPS, and then 2 layers of Advantech plywood. So that Advantech plywood becomes our subfloor, and it's just as strong as a regular wood floor, but not as hard of a surface as a concrete floor. So you can go to the next slide, please. So why not just pour a concrete slab? 9 out of 10 other builders probably would do that. A lot of people are trying to move away from concrete when possible. The concrete has a very high embodied carbon. The slab for that entire basement was around 50 yards of concrete, and concrete has creates 400 pounds of CO2 per yard, which is for that slab the equivalent of 10 tons of CO2. and that is the equivalent of driving a car around for 2 years. And we also like to keep that assembly for our framers. So this is a good rain work project. So on a rainy days, the guys can spend their time down there working on this assembly and then going back outside. There's no rush to complete this. You can go to the next slide. So for this project, we worked with National Lumber. They offer a 3D model for our project. So they'll go through and create a 3D model for the entire frame. And by doing that, we're able to size all of the framing members and pre-cut most of them before they came to site. Before we even started construction, we had the 3D model, and that allowed us to map out our mechanical, all of our mechanical layouts, and then find any conflicts before we order the frame. We were able to make any of the adjustments very quickly. And it's nice having everything pre-cut on site or before it reaches the site, because there's no waste, there's no cutoffs, everything shows up and they're numbered, and the framing crew just flies. It's a lot more efficient. You can go to the next slide. So the frame of the building consists of a 2x8 wall system. So we oversized the wall system to accommodate more of an insulation cavity. We also used TGI 16-inch TGI roof rafters, so we could have a 16-inch cavity for our roof insulation. Using TGIs required us to sort of beef up the top and bottoms of the rafters themselves, and National Lumber is able to pre-cut all of those blocks for us as well. You can go to the next slide. The entire frame has an open web floor system. We've been using this on a lot of our projects, especially the high performance ones where we have so much mechanical utilities. We have the air ventilation system, as well as our standard ductwork, our plumbing, all of our big electrical lines. Everything can run straight through those open webs, and there's very little cutting for our subs, and it goes a lot quicker on the install and the rough. What number slide is that? 23.
I don't know. The frame is the next one.
Okay, so right. So Ken mentioned some of the glue lam beams. So the core of the building, where the great room, entry, and kitchen are, is one big open space, and that consists of 8 large glue lam beams. This beam shown in the photo is a double 5-inch by 24-inch tall, 36 feet long beam. That is the structure of the floor assembly above it, and it also is the finished ceiling. So there's 8 larger beams that tie into that, and then the section where you see the gable in that photo, that is vaulted ceiling, and there's a couple more glue lam beams in there. So those are large beams that are bolted into a flitch beam. You know, we had to bring a crane to install all of those, but it's a beautiful finish. I think we have another photo in the next slide. And so this is that living room space now. So these will be treated and sealed, and those are, you know, that's the finished ceiling in that space. You can go to the next slide. So our entire wall assembly consists of a 2x8 wall filled with dense packed cellulose. On the outside, there's 2 layers of salvage polyiso. So none of the exterior insulation or rigid insulation that we use in the building, except for the Roxo, was bought new. It was all salvage material. There's a company that we work with out of Worcester that salvages all this rigid insulation on buildings that are being decommissioned or demoed, and we purchase all that through them. It's discounted and it doesn't end up in a landfill, so we're happy to use that. And you can go to the next photo. So we have the 2x8 wall assembly. We have plywood, a 1/2-inch plywood on the outside, and that's covered with 2 layers of 2-inch insulation. And then that zip plywood that you see on the outside, the green plywood, that's our weather and air barrier. Our roof assembly doesn't have exterior rigid insulation. We're able to make up the exterior insulation that we needed by using those 16-inch TGIs. So those are completely filled with dense packed cellulose as well. And you go to the next slide. And so here we are, completely wrapped. That zip is our weather and air barrier. This photo is from probably about a week or 2 ago. And we're getting ready to start installing some of the stone veneer, start installing some of the siding. Some of the brackets have been installed, but we're pretty much weather tight, airtight, and ready to start the exterior finishes.
So section Q&A for Brian. Any questions? Quiet group. I've muted some of you, so if you're speaking and you think we can hear you, we might not be able to. All right. No questions? We'll continue. Sam, you're up.
Hi, thanks for having me. My name is Sam Wallace. I'm the HVAC estimator and project manager for Lavallee Systems. We're an HVAC plumbing and electrical company that offers system design, installation, and service. And we were happy to work with Auburndale on this project. Next one. For homes like these, we use smaller all-electric heating and cooling systems. We have continuous air done through ERV systems to provide fresh air to the house. This particular house has 6 temperature zones. We have 4 outdoor Mitsubishi units, 5 ducted air handlers, and 2 wall-mounted mini splits. So any designs start with a load calculation, which you can see to the left. You can see this project, so it has about 45,000 BTUs total, which is about 4.5 BTUs per square foot. Your average code-built house has typically between 20 and 25 BTUs per square foot, which that's a lot less, obviously. Incorporating the duct layouts with the framing is very important, so getting in for design early is key, and as well as incorporating TGIs and open web trusses so we can run our branch ducts. Can go to the next. For the basement, we have 2 ductless mini splits, so we have 2 temperature zones down there. A Zender ERV is providing constant ventilation for the space, and we have a dehumidification system as well. 2 80-gallon heat pump water heaters will provide domestic hot water for the building. The first floor, we have 2 ducted air handlers for heating and cooling. We have a ducted Mitsubishi system for auxiliary heating and cooling, which is different than most homes. So the homeowner likes to have large gatherings, which makes the cooling load higher than the heating. So instead of oversizing the heating system, we install a separate air handler for when he has parties. We also installed a separate ventilation system for when the CO2 levels in the house get high. We have a Zender Q600 for constant ventilation for the first floor in the basement, as well as dehumidification and steam humidification for the winter. The second floor, we have 2 Mitsubishi ducted air handlers for heating and cooling, as well as a Zender Q450 for ventilation throughout the second floor. So the house has a total of 2 Zender systems. They provide about 400 CFM constant ventilation, as well as a Renew Air, that's an EV300 for when there are gatherings. That's monitoring CO2 levels and turns on when they get higher than a particular set point. Went through that one pretty
I was going
fast.
to say, questions for Sam? Come on, somebody's got to have some questions.
I have one question, which is, are the heat pump hot water heaters pulling the air through them from within the house, or is there outdoor ventilation that it's pulling from?
So we're not doing the plumbing, but they are, I believe, pulling from the basement space itself, not outside air.
Okay. All right. Thank you.
Absolutely.
Anyone else? Okay, moving on. Malcolm, over to you.
Hi, everyone. I'm Malcolm Sonnett from Revision Energy. We're an employee-owned solar plus residential and commercial heat pumps, heat pump water heaters, electric vehicle charging, and battery backup installer. We're based out of North Andover, Massachusetts. We've been there for about 5 years, but we've been doing this in Maine and New Hampshire for close to 20 now. So I'm going to talk a little bit about the solar aspect of this project. Ken touched on this nicely and kind of set it up, talking about some of the constraints with the shading. The house is situated perfectly for solar, but the trees presented a bit of shading issue, and that's where the pavilion in back comes into play. But this was a very exciting project because it's not often that we offset 100% electricity. You know, roofs are typically the limiting factor when it comes to going net zero. And, you know, we might get to technically 100% offset of somebody's electric bill, but it's rare that that home also has full electrification of heating, hot water, transportation, which are enormous contributors to the overall energy use. So a project like this is very satisfying where we can actually get to 100% offset. And I'll talk a bit about how we did that. If you go to the next slide. So first thing is starting with the shading and working with that constraint, evaluating each roof plane individually for potential. And you can see the bottom right there is sort of the conclusion of doing all that. You know, it's normally just wouldn't even be in consideration to be looking at the north facing roof plane, but on this house, those north facing roof planes are actually very shallow, so they can actually produce a decent amount of electricity per year. So on the left there is basically a view of looking south, where the peak of that blue line is the sun in the summertime, and the shallowest part is the sun's path through December. And so you can see, you know, lots of shade all through the morning and just a little peak there in the middle of the day where the sun pops through the trees and then goes back into shading. So all of this comes into play and is sort of summarized in the top blue lines there. We have different amounts of solar access throughout the year, and that plays into this potential of each roof plane. And then it's you know, it's running through the different dimensions of panels and different configurations and string sizing with the inverters, and ultimately getting to how much electricity can we produce on this roof. And the pavilion, as you see there in the back, as Ken mentioned, being the sunniest part of the property, that really comes into a play, especially in the winter time and with the battery backup. So you can go to the next slide, please. So overlaid in this graph here is solar potential throughout the year, the solar production rather, and then underneath that being the electricity consumption. I like to break things up into baseline loads, you know, your lights, your kind of basic, your electric cooking in this case. And for most people, this is small potatoes in the big picture. And then layered on top of that, you know, you see what a big increase the heat pump and the heating of the house and the electric vehicle charging boost to that. But you know, still able to hit 100% offset with 76 panels. These are LG 425 watt panels. They've got a great all black look to meet the aesthetic goals. They're one of the lowest degradation rates of panels you can buy today, with, you know, 0.25% loss of production each year as they just naturally degrade. So this ended up being a 32 kilowatt array, producing, you can see there at the bottom, My screen's not letting me show it.
Oh, is that 29,000?
There we go. Yeah.
Yeah.
Thank you. Yeah, nearly 30,000 kilowatt hours. So that's about 116% of annual usage. There's a little bit of loss as this monthly surplus is pushed to the next month, and that's due to just some goofy regulations with the utility. But all in all, you know, a break even on this investment of under 12 years, annual ROI of over 6%, and you know, an incredible lifetime return, net savings of 132,000. So the battery system was ended up being 5 Tesla Powerwalls with a continuous output of 25 kilowatts. So you kind of compare it to a generator, and that's what this battery system is intended to do. As I mentioned, the solar surplus kind of rolls over month to month. The reason to have battery backup in this case is to basically replace a fossil fuel generator. And so with a peak output of, well, a continuous output of 25 kilowatts, 67 kilowatt hours, what we really care about is the wintertime outage duration, because that's when the heating load is the highest and that's when the solar production is the lowest. So we look at that, and with this system, we can have 35 hours of backup in winter with really not much change in lifestyle. There's still, you know, a few hours a day allotted to electric cooking, all of the heating, hot water, you know, all the entertainment, just not electric car charging. And then when you move into the summer months where you don't have the heating loads, you have basically near infinite backup duration for an outage. And what was cool about this project is the pavilion in the back is a pretty steep array, 35 degrees, pretty optimal for solar. And it's also accessible to have the snow cleaned off by hand if needed. Then the last piece that was really interesting here, that's something, this would be the newest, this is new to us, this span smart load center. So it's a replacement of the main electric panel with smart breakers in every single slot. You know, one of the challenges of backing up heavy electric appliances is they consume so much. What happens if the power goes out in the middle of the night while you're charging an electric car, for example? So this, you can go to the next slide, please. This smart panel links to an app for toggling these, any circuit in the panel, toggling any of them on or off, setting profiles for them to automatically go off in an outage, kind of preferences, and then also getting valuable data of each circuit, the consumption of each circuit in real time. So it's a lot of, you know, this replaced 2 different other technologies that would have had to do this work. You know, we would have had to have a control to monitor all these circuits for consumption, and then we would have had another device to toggle heavy loads on and off. So this is really making a nice smooth ecosystem. And then lastly, next slide, please. You know, why we're doing this, right? This is a net zero house. All this energy, all this technology is very cool. In the end, this house is using much less per capita than the average New England home. So I think that 30,000 pounds of annual CO offset is something like the equivalent of 17 acres of US forests sequestering carbon. And I think that's all for me.
Yeah. Any questions?
Quick question.
Go ahead.
So there was no intention from the house owners to go off grid. So this whole electric system is on grid and using the net metering, right?
That's correct. This is a grid tied system. And just a quick follow-up. It's actually, there's really no benefit in going off grid. You'd have to build such an enormous battery system to be able to go off grid. And what's cool about solar right now is, and has been true for a good long time, there's this crossover where, you know, the utilities are, at least in Weston, very friendly to solar. They give good value for what surplus goes back to the grid so that there isn't a loss and there isn't a reason to go off grid. So it's nice to, you know, not have this clash that we see in states like Hawaii and California, you know, Australia, places where it's, you know, people are just cutting themselves off because the economics don't work. So this is a way for solar to work for everyone.
And one more question. For such a large solar array, when the electricity goes into the grid, is there still a limit of 10 kilowatts? Like, for example, on my system, it is there. And for such a huge system, is it still like this, or it's unlimited now?
Well, as you see, this project ended up being 32 kilowatts of DC. The AC size is just below 25 kilowatts. So there was a bit of math and you know, tweaking to get as much under 25 kilowatts of AC, because that is the, as you mentioned, 10 kilowatts is a common residential cap for full benefit net metering, 100% no loss. This project will have the surplus in those in, you know, starting in March, April, May, anywhere where the production exceeds the consumption, that surplus doesn't get quite full value, but it does get pretty, you know, 60%, and then it rolls over to the next month. So that's why when you see those final numbers, you know, production of 30,000 kilowatt hours, that's about 116% offset compared to 25,000 kilowatt hours of consumption. But what we care about is, you know, investment wise, what's the value of that solar? So 106% true value of that solar is getting pushed to the house. So it has to do with the utilities and some of those regulations. They're very arbitrary, these caps of what's the biggest solar array you can build and be into different categories. It's very arbitrary and actually on the docket to be changed hopefully soon.
Okay, any
I
other
have-
questions before we move on?
I have one question, which is, how do you deal with penetrations for conduit and all the wiring in a passive house?
Well, every penetration is going to be sealed with a spray foam. And in some cases, exterior conduit going off the edge of a roof and then into a soffit or into a gable end attic without penetrating the roof. But you know, you're talking a pretty small hole and you're filling it with spray foam in any case.
Okay, thank you.
Ryan, you want to add anything?
Yeah, all of our subs are instructed before they make any penetrations in the building to see the site supervisor. Anytime we make a penetration through the assembly, there's a few different products, but basically we'll gasket the penetration to make sure that it's completely airtight around any hole.
Okay. All right, moving on.
Thank you.
Yeah, key parts of the project. You know, we were fortunate enough to get brought into the project very early on. So, you know, Ken looped us into parts of the design and allowed us to like start building a team around the project. The house, super insulated, airtight building. It's a very, very complicated project, but you know, thinking ahead and working with the right people is making for a very successful build.
Okay. And then so here are the contact information for folks.
So yeah, people can also email us if they have questions, and we'll yeah, hopefully be able to, if we can get to in-person tours, maybe at some point later in the spring, we'll post something. It's really and we'll have some monitoring in place. It'll be cool to see all the features up and running, and yeah, it's also be cool to do a tour like a year out and show how is it actually performing. So excited to see how these span panels work. Nice work, guys. Thank you.
All right, thanks, everybody.
Yeah, Richard DePrace, he's the site super on site. He's the first one on site every morning. He's running, heavy machinery and, working alongside all the subcontractors. And there really isn't anything that he hasn't had his hands in literally on that entire project. So he's a great team member, and we're very grateful to have him on site.
I also wanted to say, with all the thanks that we show for the trades involved, we should also offer appreciation for the homeowners for allowing us to use their home for this tour purposes.